In Key Skill 7, we're going to be looking at common tangents. So first of all, we've been told that this is the equation for the circle. In Key Skill 7, we're going to be looking at common tangents. We're going to start by getting a quick sketch of the circle. So we're going to have its center at -5 plus 2 and its radius 5. So here we go, -5 plus 2, and we're going to put our spotties in. Okay, more or less it's okay. And the center of our circle is -5, 2. And we've been told that the point B is at 4, 9. So 4, 9 up here. The center was point A, so pencil that in as well. So D and E are 2 points on the circle such that the line segments BD and BE are tangents. Okay, so that means if we're joining up the tangent from here to here and here to here, one of these points would be D and one of these points would be E. Now we know from what we've studied previously that this needs to be a right angle here and this needs to be a right angle here, and that this length is the same as this length. My diagram's not perfect. I probably this doesn't really look like a right angle to me. It probably looks like D should be a little bit further over. So I'm just going to adjust it slightly. It's not super perfect, but obviously these diagrams aren't to scale, and I don't know at this point exactly where D and E are, but I can see I've marked in my right angle, and I can visualize what the problem should look like. The first question asked me to find the length from A to B. So from A to B, I'm going to find that using the distance between 2 points formula. So I can have this is x1, y1, and this is x2, y2. It actually doesn't matter which way round you have them. You can have this is x1 or this is x2, as long as you're matching, right? So as long as each point has an x and a y, and within the same point it's 1 and 1 and 2 and 2. So d squared will be equal to x2 minus x1 squared plus y2 minus y1 squared. So that'd be 4 plus 5 squared, and 9 minus 2 would be 7 squared. So we'd end up with 9 squared plus 7 squared, which would be 81 plus 49. So you add those together, 120, 130. And D would be the square root of that. So again, you can go back, add that to your diagram. So the distance from B to A is going to be the square root of 130. Next, we're asked to find the angle DBA. So from D to B to A. So we need to find this angle in here. Now we can work exclusively in this top triangle here, and using the fact that from the center to the outside is radius. In this case, radius squared is 25, so radius will be 5. So we would be working with opposite and height, so we'd be using sine. If you use the square root of 130 versus whatever the rounded number is, so if you're rounding to 2 decimal places, 11.4, you're going to get a more accurate answer. So if you can, keep the square roots in your answer. So sine theta would be 5 divided by square root of 130. So it would be 26.01. Now, if you'd been asked to, for example, find the angle D to B to E, because these triangles are congruent, this would also be 26.01. So if you needed this angle here, D to B to E, you could just double it. Find the length D to B. D to B, you can find it using Pythagoras' theorem really easily. H squared is equal to A squared plus B squared of 130 squared is equal to x squared plus 5 squared. So 130 is equal to x squared plus 25, which is 105 is x squared, and we can take the square root. roughly 10.25. In the last part, we've been asked to find the area of the kite ADBE. So this kite here, A to D, D to B, B to E here. Now, there are two ways to do this. You could use the fact that both of these triangles are congruent, okay? You could find the area of one triangle by using a half base times height, like we did in the previous key scale, and then double it to get the full area of the kite. The other way to do it would be to run the diagonals of the kite like this, and you could use the distance formula to find this distance here. AB, we've actually already got it, right? And then you could use the cosine rule to find this length here. Now, for those of you that don't know what the area of a kite is, it's a half this distance times this distance. So that would probably be a bit more difficult in this example, but that's the way I'm going to do it now because you've already seen how to find the area of these triangles in the previous key scale. So in this situation, we know that if this is 90, this is 26.02, you can do 180 minus 90 minus 26.01, and that will give you this angle here as 63.99. So double that angle would be 127.98. So if I draw this out for you, your triangle looks like this. And on either side, you've got a radius, right? So you can see that's 5, that's also 5. Now, this is a cosine rule question because you've got two sides and the angle between them. So let's call this x for the second. So the formula would be x squared is equal to a squared plus b squared minus 2 times a b times cos c. I'm going to type this all into my calculator in one go. I'm going through cosine rule pretty fast because I'm assuming that you already know how to do it. If you don't know how to do it, I've got a whole mini series on sine rule, cosine rule, and area of a triangle, so check that out. That gives me a squared is 80 or approximately equal to 80.77. To get my answer for x, I take the square root, and I've got 8.99 to 2 decimal places. So now my kite looks like this. This length here is 8.99, and this length here, we know from the part A question, was the square root of 130. So to find the area of my kite, I'm going to do half this length times this length. So area of a kite is equal to a half times d1 times d2. So if your kite looks like this will be d1 and this will be d2. So it's a half times 8.987 ... I'm going to leave it on my calculator times square root of 130. So 51.23, 2 decimal places. Just to see if you did it the other way, you get exactly the same answer. You do a half times 5 times 10.25, and you'd have two of those, one here, and you get 51.25. There's a slight difference in the answer because when we calculated this angle here, we rounded, which means this angle's also been rounded. So that's why if you use the cosine rule and calculate it this way, you get 51.23, versus if you find the half base times height method, you get 51.25. But I wanted to show you the other method because I feel like people aren't very aware of what the formula is for the area of kite. So you need to do this one times this one and divide it by 2. And if you need to get this one, you can use the cosine rule. That's been a bit long. I hope you're able to stick with me. The next key skill is not going to be so painful, I promise. I'm going to wrap this video up now because it's getting too long. See you guys soon.